Afternoon and welcome to session 2 of this AI training course. I brought up this image from last week when we covered LLMs under the hood, which was an important background and where we learnt some important lessons. Firstly, the model does not understand words, it understands tokens. The model is using pattern matching to predict the next likely token to come next. The model can be further fine-tuned to recognize other useful patterns so that it can operate in a style of a chatbot that can usefully answer questions. We also learned the importance of the context window and how getting the right information to the model at the right time can produce incredibly good results. Finally, we closed with an analogy of the LLM as an operating system, and it's here that I want to pick up today. The reason why I made this analogy is important because I want to reframe your thinking of AI away from the narrow view of a chatbot and towards the idea of a useful AI agent that can perform general purpose tasks on your behalf. I use the word general purpose very deliberately because when people talk about AGI or artificial general intelligence, it's the general part which is the most difficult to obtain. In other words, being able to throw any task at the model and for it to be able to rationalize and find a solution to that problem without requiring any handholding. There's a lot of debate as to how close we are to achieving that. And this debate rages because in some sense these models can achieve superhuman levels of intelligence, equivalent to PhD level reasoning and analysis, with extremely complex tasks. And with other tasks, it fails at the most simplistic tasks, which you may recall from our discussion about hallucinations from session 1. Andre Karpathy, who's one of the founders of OpenAI and previously head of self-driving at Tesla, often calls this the model having jagged edges. My personal view is that it doesn't matter whether AGI is close to being achieved according to some theoretical definition. What does matter is that if set up correctly, these models can do incredible things. A phrase I like to use is that sometimes it produces things that are almost indistinguishable from magic. Whether this is AGI or not is irrelevant. The fact is, it can make you super productive if you use it in the right way. The only limit is really in your imagination. One of my favorite YouTubers, a guy called Daniel Miesler, likes to say, you need to change your thinking from what can I do towards the idea, what would I do if I had 1,000 employees at my disposal? So with that introduction, I'd like to outline the purpose of today's session. Many people still think of AI as a chatbot, kind of a text in, text out generator tool. This session aims to replace that mental model with that of an agent, which I like to define as an LLM with memory and tools that runs in a loop to achieve a goal. So today we're going to see this agentic loop in action and then break that down to each of its constituent components. The LLM as a brain, the tools, which I see as the hands, the context is the memory, and the loop is the thing that cycles, and the user prompt is the goal. Everything we do from now on, including building our own agent, assumes this model of an agent running in a loop trying to achieve some goal. The session also tours all of the Claude surfaces or channels, which we briefly touched on in session 1. Claude Code in the terminal, which we already know. Claude.ai in the browser. Claude Desktop, which is the app that can be downloaded and has 3 modes of interacting, either through Claude Chat, Claude Cowork, or Claude Code. Each one of these lends itself to a different mode of interaction, depending on where it fits the topic. It gives you access to the same engine through different channels, depending on the task at hand and your personal preferences. We're also going to build out concretely on our worked example, the weekly digest agent, by demoing the full thing in section 2.1. That demo using Alex Okafor's persona and the week of noise input, which was attached in your homework, is the spine of today's session. I think we've now got a question from Richard. The question is, what are the differences between ChatGPT, Claude, and Gemini? Because we as a business have got Gemini Workspace, so we're obviously quite tied to Google. I'm hearing a lot of Claude and ChatGPT, so we need to make a call on where we put our efforts. Are there specific reasons to use each of these, or should we be putting all our efforts behind one of these platforms? So I would say there's actually very little difference between the three, because they're all just as good as one another. But there are certain nuances that you do need to recognize. Gemini, the Google ecosystem, is very good at images and some of those creative tasks, so I don't find it surprising that you're using Google. I do think they've kind of fallen a little bit behind in maybe the last couple of months because things are actually moving pretty quickly. When it comes to coding, Codex or ChatGPT from OpenAI is very, very good. And when it comes to using these agentic tasks for kind of everyday purposes, the Claude model works incredibly well, and that's the one that I typically use. So what I would recommend is don't put all your eggs in one basket, and I would say just use them all. So now that we've set out the purpose of today's session, let me outline the specific topics on the agenda for today and that I hope to cover in order to achieve that purpose. I'm going to talk a little bit about this progression towards agents and how in the AI industry there's been a move from prompt to context to agents. I'm going to walk through that with a detailed example of the weekly digest. And then I'm going to talk about each of the individual components. I'm going to talk about context management. I'm going to talk about tools. I'm going to talk about artifacts. And then I'm going to bring all of that together when we talk about these different components together, forming what is called the agent harness. This week, we're going to cover what's called the inner harness. And then we're going to tee up next week's session where we cover what's called the outer harness. So the following diagram illustrates how there's been this progression in how we maximize value from AI. Agents are, of course, the current chapter, and themselves have been going through different phases of maturity. In 2023 and 2024, everyone was talking about prompt engineering as the hot topic, where you try to find the right words to get the best results from the LLMs. This is still important, but is now considered entry-level practice rather than advanced level. The basic ideas, such as setting the stage for the role, where you tell Claude who it is in this particular interaction. For example, you're a risk analyst reviewing a trade portfolio. That's very important. Of course, defining the task by stating exactly what you want done in very precise terms. Specifying the rules in terms of style, tone, output format, word count, any don't do items. And of course, good examples help a lot here. And then, of course, adding context with relevant files and other background information. You will recall that we've already talked at length in session 1 about how adding the right context ensures you get improved results. Then, in 2025, we had the rise of context engineering, which we will talk about at length later in the session, where the latest practices are all about ensuring that the context window, in other words, what the model can actually see right now, matters much more than how you ask it. Now, in 2026, the latest practices are all focused on agents and ensuring that the model is not just focused on answering, but rather what is it doing. It is tools, it loops, it is memory, and that's what today is all about. There's a new phrase for that, which those working in the AI space are using, which is called harness engineering. I won't dwell on this now, as it's very specialist to us AI geeks, and we'll pick up on again later in the session. For now, I want to focus on the terminology, which is much more widely known, which is AI agents. Right, so next I'm going to move on to the AI agent loop. We saw earlier that my definition of an agent is an LLM with memory and tools that runs in a loop to achieve a goal. And I want to contrast that against a chatbot, which has limited tools and no memory beyond the current window. It's the same brain, but vastly less capability. In the diagram on the screen, you'll see visually how this agent loop works and the key components where I use a human analogy, which are the brain. This is the LLM. It reads, thinks, decides what to do next. So this would be a particular model, for example, Claude Opus or Sonnet, or for OpenAI, like ChatGPT 5. Next, you have the hands. These are the tools that the brain can call to do things. Read a file, write a file, run a bash command, search the web, those type of things. And then you have the loop. This is this repeated cycle of read, think, act, observe, and repeat. And every modern agent has this type of loop. And then lastly, we have the input. And this is the goal or the target that the loop is trying to hit, but also includes any additional context or memory that we add. For example, generate this week's weekly digest. So that might seem a little bit theoretical. So I think the best way to explain this loop is to use an actual example that you can see it in action. And then afterwards, we can come back to the diagram and see exactly how this loop happened in a worked example. So naturally, I'm going to build on our weekly digest example with Alex Okafor, who we used before. I'm going to do this in Claude Code because it'll give us the most visibility into the actual loop compared to other channels such as Claude Desktop, where some of the details are a little bit hidden from view. So I'm going to do this in the terminal, and you can see I've opened a terminal screen on the right-hand side here. And the way you access the terminal screen, if you're on a Mac, is to simply look in your Spotlight and you can find the terminal app. And so I've opened this up, and now what I'm going to do is I'm going to go into a particular directory on my computer. I'm going to do this by using a command called cd, which stands for change directory. And if I run that command, you can see cd. I've actually changed into the directory called Weekly Digest, which is on my computer. And so now that I'm in this folder, I can run something called the ls command. And ls command stands for list. All that's doing is when I run that, it's listing whatever's inside of this Weekly Digest folder. And inside this folder, I have a claude.md file. I have another folder called inputs. I have a file called instructions.md and a file called persona.md. So if I try and explain each of these in turn, persona.md you're all aware of because that's the persona file that, first of all, you did for your homework. But in this particular case, it's the Alex Okafor persona file, who we've seen already. And then we have this file called claude.md. Now, this is a special type of file that's auto-loaded every time that Claude runs. And basically what it's doing is it's telling Claude what this directory is about. So, for example, in this one, it's going to say, there's a persona file, there's an inputs folder, and there's a week of noise file. So it just gives it a little bit of advanced notice of how to navigate this particular directory. Then this instructions.md, this is a new file that we haven't seen before. What I'm going to do is I'm going to go in and show you what's inside this file. And I can do this by running a command called cat, which stands for concatenate. I look for cat instructions.md, and that actually opens the file in the terminal and shows you what's inside. In this particular case, I've got a set of instructions which tells Claude to produce this week's weekly digest from the notes in the inputs directory. It tells it exactly what to include. It tells it to filter aggressively. It tells it a required format. So it needs to follow this exact structure. And then further down here, I've got some constraints. For example, that it needs to fit in under 350 words. It needs to use bullet points. It needs to exclude noise. So these are just some of the constraints that it needs to apply. And then there's a final step, which is called self-check. And it's basically saying after writing the file, it needs to confirm certain things. Certain headings are present, that the front matter has both week of and persona filled in. Each section uses bullets, not paragraphs. The word count is under 350. So these are the various checks that it needs to apply. So that's basically what this instructions file is telling us. Okay, so now we have a question from Maxim. Maxim's question is, I'm curious how well in your case AI follows instructions, because in my experience, it follows it for a while and then some start to forget the instructions. So good question, Maxim. And what we're going to see in a moment is whether it actually follows the instructions that I've given it. I would say for this, it's going to follow it extremely well. The reason is that we're going to have very little in the context window, other than just these few items. So it's going to be pretty good at following those instructions. If it's not following your instructions, I'd say it's because you are seeing what they call context rot, which is where you put too much in the context window and it starts to get confused because there's other things that are taking away some of the attention from the main task. So if you manage to keep the context window clean, I would say it's going to be very good at following those instructions. And that's basically how you ensure that it keeps focused. So hopefully that answers your question. Now that we have an idea what's actually in that instructions folder, I'm going to do one last thing, which is if I run this ls command, you saw we had this inputs folder, and I'm going to cd into this inputs folder, and then I'm going to run the ls command again. And you can see inside this inputs folder, we have this week of noise, which of course, again, we know from the homework and from the previous digest for Alex Okafor has got his of noise. So what I'm going to do next is I'm actually going to open Claude. And to do that, I run the command Claude. First of all, use cd ... which takes me back one step into my weekly digest folder. And then I'm going to run Claude inside my weekly digest folder. We've now got Claude started, and I'm going to give it a prompt. And in this particular case, the prompt is going to be deliberately vague because I want it to be a high-level goal where Claude needs to iterate through the loop until it is decided that this goal has actually been achieved. So in this particular case, the prompt I'm going to give is figure out what needs to be done, a deliberately vague goal. And if I press enter, Claude is now going to iterate through the agentic loop until it's determined that this goal has actually been met. So we'll wait until this has actually been completed, and then we'll pick up again there. Right, so that's now completed, and it took a total of 1 minute and 29 seconds. And as we see, Claude has correctly followed the instructions and written the digest to this file. So it's completed its loop, and that's good. The first thing I'm actually going to do is I'm going to run a command here, which is Control O. And what that's going to do is it's going to expand things out and it's going to show us a lot more detail. And I need to do this because this is going to help us explain the full loop and all the iterations that Claude went through. The first thing we did was we obviously put in the goal, figure out what needs to be done. At this stage, the LLM is trying to figure out what needs to be done, and it says, should I call a tool? But of course, all it knows is figure out what needs to be done. So it says, of course, I need to use a tool because I don't know what needs to be done. In this particular case, it's used a tool called bash. And bash is a tool which allows you to run commands such as ls. We know what ls is because I just ran it earlier. And that is just to list what's there. So Claude runs the ls command, and you can see it finds out that there's a claude.md file, an inputs directory, an instructions.md file, and a persona.md file. So it's got that information from the tool, and it comes back here to call the LLM again. And it says, okay, well, now I know what's in there. Now, should I use a tool? Yes, I should use a tool because now I know what's in the directory. I can use my read file tool. And you can see it's using this read command here to go and read the persona.md file. What it also does is it then runs the ls command again on the inputs directory. And in the inputs directory, we know the file that's inside that inputs directory is weak of noise. So it now knows what's in that inputs directory is the weak of noise file. It now comes back again. Have I got everything I need? Well, not yet. It says, of course, should I use a tool? Yes, you should use the read tool. And in this case, it reads the weak of noise file. So it now knows what's in the weak of noise file. It now has got the persona file, it's got the weak of noise file, which it's read. And so now the last thing it does is it needs to again read file, because this time it needs to read the instructions.md file. So it reads this file, and now it comes back again and says, okay, can I figure out what needs to be done? Well, in this case, it says, I have the persona, inputs and instructions, drafting the digest now that's under 350 words, bullets only, no hype and signal only. So it has all the information it needs, and now it can actually call the LLM, which is all the pattern matching, which we saw from last week, and is starting to write that weekly digest. And once it's done that, it comes back and says, should I call a tool? In this case, yes, I should. I need to call the right file tool. So it writes the weekly digest to this particular directory. And there you can see some of the detail. We'll go into that in a moment. And then it comes back and it says, have I completed everything that I need? No, it hasn't, because in this particular case, the instructions said that you need to do some self-checking. So it says, okay, I need to do some self-checking against all the requirements. In order to do that, have I got everything I need? No, I need to call a tool, and this time I need to call a read file tool. And this is important because actually, although it wrote that weekly digest file to the directory, it now needs to read that back into its context so that it can run the checks that we want it to. So it reads this file, and once it reads it, it brings it back again and says, okay, have I got everything I need? In this case, I need to call a tool again, and this time I need to call the bash tool again, because I need to run some checks to see that all of those checks that we listed in our instructions have been met. So it runs this command, and this is called a regex, a regular expression. And what it's doing is it's checking for the formatting, the bullets, all those type of things. And it now comes back and it says all the self-checks have passed. So we're back at the call LLM phase, and it says all of these have been done. And if all of these have been passed, you can see all the ticks. It's yes, I can. And in this case, it says weekly digest written, and it comes out of this loop and displays the text that has done all of the tasks and has met the overall goal. So that is really the whole of the agentic loop for this, somewhat simple example, but you can see exactly how this loop iterates through each time, and every single time what it's trying to do is it's trying to say, have I met the actual goal that's been given to me? And it uses tools to figure out if that's been met, and then if necessary, calling the LLM, and then finally displaying the results. So we have another question, and this time from Liesel, who's saying, so when you say it's actually writing the file, is that to Obsidian? So the answer is not specifically to Obsidian, but rather to the actual folder that you asked it to write to in our actual instructions. In this particular case, we asked it to write the digest back into the weekly digest folder on our computer, and that's indeed where the file has been saved. But since this is just a markdown file, then of course it's still possible for this file to be viewed in Obsidian. If you put a copy or move this file into the same folder as your Obsidian Vault, then you'll be able to see it in Obsidian. And the reason is that Obsidian is just a Markdown file viewer application. So as long as the file is in Markdown format, then Obsidian can be used to view it. Of course, we can actually go and have a look at that file. And to do that, I could open another terminal window. And if I open this terminal window and I go using the cd command back into our weekly digest folder, and if I run the ls command again, you'll see this time is our claude.md, our inputs folder, instructions, and persona, but we also have a weekly digest file, which has been written into this weekly digest folder. So in this particular case, what I'm going to do is I'm actually going to use the cat command to look at this digest. And if we look at the digest, it's basically followed the exact format, week of, the persona, weekly digest for this week, where the time went, which is what we asked it to say, what moved forward, what slipped or stalled, what to chase or flag for this week, and next week's priorities. So, and in this case, I know it's under 350 words because Claude checked that. So it's met all of the requirements that we asked it to in this particular case. So now we have a good feel for the loop. I want to go into more details about each of the steps in this loop. And we're going to be starting with this input section, which is all of the information that we feed into the model. And of course, this information, as we already know from session 1, is in fact the context window. I know there's a lot to take in on this diagram, but I'm going to walk through step by step and break it down using the weekly digest example that we just ran on Claude Code. So just to recap, the context window is the input that gets loaded into the LLM to start this loop going. And although it seemed to us like we just asked, figure out what needs to be done, there's a lot more that gets sent to the LLM than meets the eye. I'm going to start with the current user message because this is obvious and of course very visible. In this case, we ask it to figure out what needs to be done. And that of course goes into the context window as our instruction into the LLM. But what you don't see is that there's hidden from you is that there are other files that are automatically included in the context window at the start of every conversation. Looking at the left of the diagram, we have the system prompt. This is the message that's been designed to make sure that Claude conforms to certain behaviors as well as other basic information. Take, for example, child safety, where an excerpt from the current Claude system prompt includes the following. Claude cares deeply about child safety and exercises special caution regarding content involving or directed at minors. Claude avoids producing creative or educational content that could be used to sexualize, groom, or abuse or otherwise harm children. So that's an exact excerpt from the system prompt on Claude Opus. And obviously that's the type of things that it's trying to do to make sure that Claude behaves in certain ways where that's how it's expected to behave. Some other simple examples of things that are inside the system prompt is things like who is Claude? So it knows, for example, that it's a useful AI assistant. It includes information about the current date and time. You'll remember from session 1 that the LLM was trained on internet data and that takes months of work. So naturally it was cut off some months ago, and on its own, it has no idea about what the date and time are. So the system prompt tells it this. Of course, that's very useful if you're going to be asking about specific date and time queries. The full system prompt, as I mentioned, can be found on the Anthropic website, and it's specific to each particular model. Next, we have the claude.md file, and we saw that earlier. In other LLMs, such as ChatGPT, they have an equivalent file, but it's obviously not called claude.md. It's called agents.md. And this file is optional, but it's very useful to guide the LLM about how it should act when you're working in a particular directory location. In our example, the file contains information about the persona file, the fact that it's a subdirectory called inputs, and the other files there. You can have different claude.md files in different directories because each directory obviously contains a certain project, and whatever's in that project is going to be very, very different. So basically this file helps the LLM get up to speed very quickly about the nature of the project or the information in that directory. Next, we have the conversations so far. This contains each of the user queries as well as the assistant responses. In our example, we had one question at the beginning, but there were a few assistant responses as it gave feedback through the various iterations of the loop, as well as the final response about the final digest that was written to that particular weekly digest folder location, and the fact that it indeed performed those verifications that we asked it to. We could, of course, carry on with the conversation, in which case the old ones as well as the new ones continue to be added to the overall message in the context window. window. You'll also recall from session 1 that Tiffany had a great question about whether we need to clear out our context window or perhaps start a new session. And I explained that the LLM has the capability of compacting conversations. So you'll remember that. And in this diagram, you can see there's a section which is included for the compacted summary of all those older messages. And finally, here on the right-hand side, you can see the various tool calls and the files read, which you'll recall from our weekly digest example. It had to read the instructions and the persona files into the context window before it could act on that information. When the compaction happens, these results are also trimmed down to free up further space. You also recall from my compaction answer in session 1 that you can compact whenever you want, not just when the token consumption gets up to the maximum amount. So one neat trick when you perform compaction yourself is that you can compact but also specify certain instructions about keeping full details on a specific topic that you don't want to be summarized. That way, it won't trim down or summarize for that specific area, but will for the rest of the context window. And finally, of course, there's a section here for the free space that hasn't been used. So I walked you through the different elements of the context, but probably still feels a little bit theoretical. So I'm going to come back to our weekly digest, and I'm going to give you a little bit more transparency into the actual context window for this particular example. So I'm going to pop back here into my demo session of Claude Code. So if I open that, and I'm going to run a command here called /context. Now, once I run this command, this is actually going to show us everything that actually appears in current context window. So you can see context usage, and we've got categories for all the different things that are inside the context window. So we've got the system prompt, which of course we saw earlier. And that's consuming 9,800 tokens, or 1% of our total context window. We've got system tools. So these were the various tools that are needed to do the read, write, bash command, etc. Got memory files, which you'll see a little bit lower down is our claude.md files. There's skills, which we haven't touched on, but is a big topic for us to cover next week. And these are basically just things which help Claude personalize to your particular requirements. And then there's the messages, which of course is our conversations so far. And then you can see the free space. If I scroll to the bottom here, you will see memory files is indeed the claude.md file. And you can see there's a variety of claude.md files because it's the one in our current directory, but also ones at higher level directories. So for example, in my life.claude folder, there's a claude.md file. And in the life folder, there's also a claude.md file. So there's 3 separate claude.md files through the whole hierarchy of where you find this weekly digest folder. I also skipped over this MCP tools. Now these MCP tools, these are really external tools because the tools that we had like read, write, bash, those are tools which work locally here on my computer. But of course I might want to use external tools that connect to systems outside of my computer. And that's what these MCP tools do. And we'll talk about those when we come onto the section on tools a little bit later. So most people never really look at this context detail, but as you know, given the importance of managing context, you should be looking at this as often as possible to make sure that whatever is in your context window is going to be clean and relevant to exactly what the task is that you're working on right now. I'm conscious that we've been working in Claude Code and not all of you are familiar with working in that environment. So I'd like to show you how this works in another channel as well. In this case, we're going to move to Claude Desktop, which is the Claude app downloaded from Anthropic website. Of course, there's an equivalent one for ChatGPT, which is called Codex, and also one for Google Gemini. And so I'm going to launch Claude Desktop. So on the left-hand side of Claude Desktop, you'll see this section here called Projects. And if I click on the Projects folder, on this Projects tab, you'll see I've created a project called Alex Okafor Weekly Digest. I'm going to go into this folder here. Now, the idea behind projects is that if you have something specific that you want to work on repeatedly, and don't want to pay what's called the context repetition tax. In other words, you don't want to have to continually add context, which the model should have access to every single time. And in this particular case, that's the instructions.md and persona.md, which I've added into my project folder here. And in this particular case, what I've done is I ran a prompt earlier where I said, can you prepare my weekly digest? And then I've added the week of noise file. And I asked it to execute that prompt. And so it ran and it said, I'll prepare your digest from your week's notes, filtering to signals and following your stated format. It's of course running the self-check that we asked it to in the instructions. It's showing it passed the self-check, and then what it's done is it's produced our weekly digest. And if I open the weekly digest, you'll see indeed it's followed the right format, where time went, what moved forward, what slipped or stalled, what to chase or flag this week, and next week priorities. So exactly what we saw from the Claude Code session, and this is completely independent, and it followed the same instructions and also did exactly the same type of work that we saw in the Claude Code example. I also want to show you a little bit of some of the detailed thinking. So of course I can click in here, and this shows you some of the detailed thinking that goes behind the loop which it went through. So it says I need to create a weekly digest for Alex Okafor, putting together the persona details, instructions and notes. I can expand that so you can see all the detail here. You can see the detail behind the verification that it did, and then all of the validation that it did as part of that, doing the self-check. So that's exactly the same loop, except this time it's been done on the Claude desktop app as opposed to Claude Code, which we ran before. Now, a quick observation test. Can anyone see anything different about these attachments? So, for example, if I come in here, I have two attachments here, our instructions file and the persona.md file. And then I added the week of noise attachment onto the actual query that I asked Claude to do. Now, why would I put the week of noise file in here and yet add the instructions and persona file here in the project folder? Now, there's a reason for that. And the reason is that all of these files that you see here in the project section are loaded into the context window every single conversation turn. So in a way, they're almost scaffolded in the same way as the system prompt and the claude.md files. So if you want to run a weekly digest, say next week, I don't want this week's week of noise to be added to the conversation. And so therefore, I added it as an attachment in the chat rather than the project file. And this is a very important distinction to be able to manage the context window size, because I don't want weeks and weeks of week of noises being added every single time, and then I don't want last week's file to pollute this week's weekly digest. But of course, if all these project files are being added into the context window every single time, you may be asking what happens when you have a very large number of files sitting there taking up context window usage. Well, Claude actually has a strategy for how to deal with this when your project files exceed a certain size. So in that particular case, they're not automatically loaded, but rather it employs a technique called retrieval augmented generation, or RAG for short. Now, please bear with me for a bit, as this can be a bit technical, but if you listen well in session 1, you may just have an aha moment. So I've created this slide on retrieval augmented generation. And again, there's a lot in here, but let me show you step by step what each of these things is doing. So what happens when you ask a question in the chat is that your question is converted into embeddings. And embeddings are a numerical vector representation of the words. Now, I hope you all recall from session 1 how the word king had a numerical representation that ensured it clustered around similar words such as prince or queen. So once your question has this numerical representation, so Claude can go into your project files and pull out just the relevant excerpts that have similar numerical representations and load these into the context window. Since these excerpts have similar semantic meaning, it's highly likely that they are relevant to answering your particular questions. So now why this is important in practice is because if, for example, in this case, you're working for maybe the Sharp agency, as a specific example relevant to both Mandy and Richard here, and you wanted the model to understand a lot more information about the Sharp agency, including about particular projects that you're working on at the Sharp agency. And so you're going to start putting these files into the project folder. It might be a specific client as well as a specific project for that client. And of course, you're going to start accumulating much bigger files and much more information into this project folder. And that's important because you want the model to understand that context, and you want it to understand that context every single time you ask it a question. But there's a problem in that eventually it creates very large files which you're loading into your context every single time. And what happens is that those files become so large it starts using up too much space in your context window. So that could be a problem. Claude then uses this RAG functionality to keep these large files from eating into your context window, but still making them available when you need to provide necessary context to answer a specific client or project question. We have another question this time from Richard. So his question is, can files from Word documents or website URLs be added, or would it have to be text files? The answer is you can provide Word documents or website links, but the problem is it's not very efficient. The reason being that with a Word document, what the model is going to do is it's going to take that Word document and it's going to use a tool, in this particular case, a Python script, and it's going to extract the text out of that Word document, and then it's going to use the text to feed into the context window. So there's an extra step which you really don't need in this particular case. Now, when it comes to website URLs, there's also unnecessary information that we don't want to be added to the context window. And the best way to show this is to use an actual example. So I'm going to go to some random web page. In this case, the Wikipedia page about Tiger Woods. Now, this looks very nice to read for us, doesn't it? So I'm going to show you what the model sees when you give it a URL. So if I right-click on the web page and click View Page Source, this is actually what gets loaded into the context window for the agent to see. Isn't this horrible? It contains not only the text that we want to read, but also various HTML code blocks that allows the web page to be able to render it in a nice formatted way. And that's why giving it a URL is not very efficient, because there's all of these HTML properties and formatting, and every single one of these things is consuming tokens. And it's going to be loaded into your context window, and that's highly inefficient. And that's why I said what you really want is as close as possible to pure text. So I promised I was going to move on to tools next, and you already saw in action earlier when Claude Code used the following tools. It used the read file, it used the write file, it used the bash command. Other important tools that we didn't use were web search and web fetch. And of course, these are going to be important to allow the model to get up-to-date information directly from the web. And just with these tools alone, it can do an awful lot, especially the bash command, since it means we can execute code locally and your computer can perform a lot of tasks just by using code. The real power, however, from tools comes from being able to connect to external services, for example, email or calendar or other tools provided by outside companies. And we touched on this earlier when I talked about MCP servers. And I mentioned that we would come back to this when we talked about tools. So I don't want to go into the technical details, but what they are, the way to think about it is that they're a universal standard, which was developed by Anthropic and has now been adopted across other LLMs for plugging into external tools. So email, calendar, any other company that has a tool that you want to interface to uses these MCP servers, and that's just a standardized way of accessing those tools. The best way to illustrate this is to use an actual example. So I'm going to come back to Claude Desktop. Now I'm going to come back to Claude Desktop, and our goal this time is to build the equivalent of a week of noise from your actual calendar entries. And before I do anything, I'm going to show you on the left-hand bar under this Customize option. If I click on Customize, you'll find a button for connectors. And in this case, there's various connectors which I have connected onto Claude Desktop. And if I come here to Claude Calendar, you can see I've got Claude Calendar connected and I've given it various permissions. And of course, I can change those permissions should I want. So this just shows you some of the connectors that you can add, and this is using MCP servers in the background. Now, if I come back to the chat and I open this weekly calendar digest compilation, this is one that I ran earlier, and I put in the prompt, look at my Google Calendar for the past 7 days, produced a markdown bullet list of every meeting and event with date, time, attendees, and where available, the subject. Group by day. This is going to feed into the weekly digest later. And what's happened is it's gone into my calendar and it's pulled that full weekly digest. It didn't follow the specific format that I wanted. So what I did was I actually asked it the same question, but this time I added the weekofnoise.md file and I said, try to use the format of the attached version from a previous week. And again, it looked into the calendar, and this time it produced a file which follows the exact format that we asked it to. 23rd to 30th of April, raw calendar notes, each day, with the time and the details. So in this particular case, you can see I had lunch with Polly at the Pig and Butcher. I've been working on the AI session on video editing. I had my Tesla pickup by British Car Auctions. I worked on DaVinci Resolve to do some YouTube tutorials so that I could edit the videos. So this is my equivalent of the week of noise, but actually coming from my real calendar entries. So that shows you just the power of using some of these external tools and how we take what would have been a pretty manual task, and you can automate that using those tools. So the next topic I want to cover is artifacts. In our agent loop diagram earlier, the final output was text, which is what we expect from a large language model. However, it doesn't always need to be a blob of text. It can be a document, a diagram, or some sort of interactive component. So we already saw this when we produced the weekly digest earlier. if I scroll further down here and I click on this, our weekly digest was produced, and this on the right-hand side is what Claude Desktop calls an artifact. So this is now just a markdown file, and it's been nicely formatted in the way in which we wanted, but it's a simple artifact. But artifacts can be more sophisticated, including web pages, images, mermaid diagrams, and other interactive features. So I thought it'd be useful to show you a little bit more. So if we stay in Claude Desktop, come back into the weekly calendar digest, and in this particular case, after it produced the weekly digest, I added a further prompt which said, turn this into a one-page visual dashboard I could share with my team. Show the time breakdown by category, flag the longest meetings, and add a small section for next week's calendar. And of course, it thought about that, and then it created, down the bottom here, an interactive artifact. So if I open this up, on the right-hand side, you can see it's a beautifully rendered artifact with how my week actually went, the amount of time scheduled, where the time went, longest blocks of the week, and then that looking ahead section that we asked it to add. Now that's not all. What I can also do, if I close that down, it also shows me I can open this in Google Chrome. So if I click open in Chrome, there we can see my artifact opened in a web page. So that's just another way of seeing those artifacts. And there's one more feature that I want to show you. If I open this artifact again here, and if I look on the top right-hand side, and I click here, it has this button, Publish Artifact. And this allows me to publish this as a link, which I can then send to other people who can then open that link. And then later on, you can also make that interactive, and you can have kind of a back and forth with people using that live website link. So that's just a little bit about artifacts and what you can do with some of them. So now I'm going to come back to the agent loop diagram again. Everything we just covered, the context management, tools, artifacts, all of this has a name. In the AI industry right now, it's called the agent harness. You'll hear both harness and scaffolding used interchangeably in articles, tweets, and product announcements from the model companies like Anthropic and Claude. But right now, this is where significant effort is being placed because, as I mentioned earlier, the better the scaffolding or harness is, the more complex the tasks are that can be undertaken by these models. Just knowing what this is and how it works, you're now already on the cutting edge of AI conversation. So these tasks, as I say, can be really complex. Although our particular task was not that complex, as it only took less than a minute to run. We're now at the stage where all of the harness or scaffolding that goes around these models is so good, you can give it a task which you can run for hours. In fact, I wanted to build a website probably about 2 months ago. I gave it instructions and it ran overnight. It ran for, I think, about 6 or 7 hours. And when I woke up in the morning, I had a fully functional website that was pretty much as per my specification, with maybe another half an hour of tweaking. Got another question now from Andy, and he says, I've started using Claude within VS Code, which I find is really neat, but there's a function at the bottom of the terminal where you can say ask before edits or edit automatically. There is another one which I've not been using called auto mode. So when I put edits automatically, it still stops and waits for me to confirm that it should progress. So it doesn't edit automatically. So I'm just quite surprised that you're able to leave it running overnight. So to answer your question, that's because I was running in a mode called dangerously skip permissions. So then it has access to do whatever it needs to do on my computer without me having to give it permission. You mentioned that you might be scared of running in dangerously skip permission mode. But in my case, I've got an extra layer of protection that I've been using, something called hooks, which we'll cover in a later session, where it looks for especially dangerous commands like delete all files from this folder, and it stops those commands from being run. So I can illustrate this on Claude Code right now. If you look on the right-hand side, I've got the Claude Code session that we had open earlier. In the bottom, you can see we're in auto mode on, which is the one mode that you mentioned. And we can cycle through different modes, but auto mode on is a mode that kind of learns what sort of permissions you typically use, and then it kind of figures that out on its own as to whether you really want to ask for permissions or not. So that's what auto mode on does. And if I use Shift Tab to cycle, here you can see this accept edits on, and that's the mode where, of course, it's going to ask you every single time to if it wants you to run that command in that particular folder. And then there's another mode which is called plan mode. If I Shift Tab once more, it goes into plan mode, which is the mode you should be using when you just start out on a complex project and you want to use Claude to have a back and forth brainstorming session. The reason this mode works well for brainstorming is because it doesn't have to multitask on both thinking as well as writing tasks, and so it can give its full concentration on the brainstorming rather than actual code writing. So just coming back to our agent loop diagram again, I want to make an important distinction between what I would call the inner harness versus the outer harness. And the inner harness is this part here in the middle, which is where it's kind of running these different tools And these are the tools that are provided from Claude Code itself. And these are the ones that come out of the box. And then the outer harness is going to be all the things that we add to personalize this agentic loop. And this is the topic that we're going to pick up on next week, where we start adding skills and other things like our persona file and other contexts which we give it to personalize our agent to do the things that we want it to do. I also want to quickly touch again on the different ways of using Claude. So we've already used 3 in a session. We used claude.ai in the browser chat with projects and artifacts. We used Claude Desktop, where we went in and created some of those artifacts. And then we used Claude Code, which is where we saw our agentic loop. The one that we haven't touched deeply on yet is Claude Cowork. And we're limited in time now, so I just want to touch very briefly with a specific example of Claude Cowork. So if I open Claude Desktop, you can see Claude Cowork at the top here. So if I come into Claude Cowork and I come into this specific example we have here, I added my week of noise and I gave it a prompt. I have a task that I would like you to schedule. The task is as follows. Look at my Google Calendar for the past 7 days. Produce a markdown bullet list of every meeting and event with date, time, attendees, and where available the subject. Group by day. This is going to be fed into the weekly digest later. Try to use the format of the attached version from a previous week. And of course, what it's done now is it's created a schedule to run every single week. So if I come into my scheduled tasks on the left-hand side, you can see I have a scheduled task. And if I go into this, you can see it pulls the past 7 days of Google Calendar events into a markdown bullet list, grouped by day, formatted to feed into a weekly digest. And it's active. I can toggle it on and off. The next run is going to be on the 11th of May at 7 a.m. because I scheduled for it to run every single week at 7 a.m. So this is an example of how Claude Cowork, you can actually have these scheduled tasks, and that can help you automate various items. So just to recap, we've covered this inner harness, and next week I said we were going to cover the outer harness. That's where we build the actual agent that's yours. And today we talked about context management, the window, what feeds it, how to look inside it using the /context command, and how to put things into the projects folder. We talked about tools, which are the hands that allow the model to read files, process bash commands, and perform web search, as well as external connectors like Calendar or Gmail if you wanted to look into your email via MCP servers. We looked at artifacts and outputs, which are not just text documents, but real web dashboards and other interactive dashboards. And then we covered the different surfaces like Claude Chat, Claude Desktop, and of course Claude Cowork, which is basically the same engine, but in a slightly different surface. So that's all the things I wanted to cover for this week. And next week, we're going to pick up on skills, which are the first piece, as I said, of the outer harness. And we'll start seeing where we can build some of those skills for your agent. So see you all next Friday.